Hi, thank you for joining me. In this little video clip here, I want to cover numbers 4 and 12 on the semester exam study guide. Numbers 4 and 12 have to do with regular polygons. Let's look at number 4. Claire is drawing a regular polygon. So the key word here is regular. She has drawn two of the sides with an interior angle of 140 degrees as shown below. So when we see the term regular, we have to know that a regular polygon, all sides are congruent and all interior angle measurements are equal, or all interior angles are congruent. Okay, so that's what we're talking about. We're talking about a polygon whose interior angles measure 140 degrees. So the question is, when Claire completes a regular polygon, what should be the sum in degrees of the measures of the interior angles? So we need to find the sum of all the angle measurements. Um, So remember, what we can do is if we can find the number of sides, we know the number of angles. And then we can use that to find the sum of the angles. So remember the expression n minus 2 times 180? That gives you the sum of the angles of the interior of a polygon. Okay? And that's a regular polygon or not. N minus 2 times 180, where n is the number of sides. I can use that expression to find the sum of the angles of a polygon, of the interior angles, where, again, n is the number of sides. So if I have an octagon, which is 8 sides, I can say 8 minus 2, which is 6 times 180, and that would give me the sum of the angle of the measures of the interior angles. Now, if I were to divide that by n, still being the number of sides, that would give me the measure of each interior angle of a regular polygon. Okay? Because remember, all the interior angles of a regular polygon are equal. So, for example, a quadrilateral, the sum of their angles is 360. If I have a regular polygon like a square, 360 divided by 4 is 90. Each angle measures 90. Okay, I divided 4 by the number of sides, which is also the number of angles. So what I'm going to do is I'm going to take this expression here and I'm going to rework it so that I can find the number of sides. If I have the number of sides, then I can multiply it times 140, and that'll give me the sum of the angle measurements. Okay, because again, the number of sides is the same as the number of angles. So if I take n minus 2 times 180 divided by n, that has to equal 140, because remember we're creating a regular polygon, and one angle measurement equals 140. And remember, this gives you the angle measurement of one angle of a regular polygon. So if I rework this to get all my n's in one place, I can multiply both sides by n, and this n will cancel out. What I do to one side, I've got to do to the other. And so what I end up with is n minus 2 times 180, these n's cancel out, is equal to 140 times n. Okay, so think about this. The n minus 2 times 180 is the sum of the angles. Okay, if I multiply 140, the measure of one angle, times n, the number of sides, I've got the sum of the angle measurements. So these two statements should equal each other. All right, so think about that a second. All right, so now I'm going to distribute this 180 and have 180n minus 360 is equal to 140n. Okay, then when I add 140 to each side, or excuse me, subtract 140 to each side, and then add 360, I have 400 or 40n is equal to 360 when I begin solving for n. Then I divide by 40 and n is equal to 9. So the number of sides I have, if I'm going to have a regular polygon with each angle measuring 140, I'm going to have 9 sides. If I have 9 sides, I have 9 angles. So using n minus 2 times 180, 9 minus 2 times 180 is 1260. Okay, the same as 9 times 140. All right, so that's number 4. Hope that helps. And then let's look at number 12 because it also is has to do with regular polygons. So looking at number 12, we have a regular hexagon, which is 6 sides, and a regular heptagon, which is 7 sides, as shown below. Okay, so we have a 7-sided regular polygon or 6-sided and a 7-sided. And the question is, what is the measure of x? So notice that all 3 of these angles equal 360. So the plan would be to find these two angle measurements, subtract that from 360, and that would give me x, this angle measurement. Okay, and so we know the number of sides, so we can find the sum of the angle measurements and then divide by the number of sides or angles and get the measure of one angle. So using n minus 2 180 times 180 for the hexagon, the difference of n and 2 times 180 for the hexagon, we get the sum of the angle measurements is 720. So when we divide by 6 the number of angles, we have one angle measurement that's 120. Do the same for the heptagon, and we find that each angle measurement for a regular heptagon is 128.6. So if I subtract 128.6 and 120 from 360, what's left has to be x, which is approximately 111, or exactly 111.4. Okay, so that's regular polygons.